Hi everybody, happy Monday. Hopefully everyone had a great week last week. And here we are into our last full week of math. We are starting our second last unit, Unit 6, Exponentials. And I've trimmed this down to a very short unit. So this unit's going to be basically 2 days. And just so you are aware, if you haven't looked at the timeline yet, your test is going to be tomorrow. And instead of it being in the morning, it's going to be in the afternoon. So we're going to end the day with your test. And then on Wednesday, we're going to start our last unit. With it only being 2 days, there's not going to be an assignment for this unit, only a test. So we're going to have a couple of quick lessons in the morning. We'll do one more in the afternoon. Then tomorrow, Tuesday, we'll do our last lesson first thing in the morning. We'll do a couple of review things together before lunch and maybe shortly after lunch. And then your test will open up probably around, let's say, 1 o'clock. And then you'll have 2 hours, a 2 hour and 10-minute window from 1 until 3 to complete your test. And on that way, your last unit, which is finance, there is an assignment with that. So we'll be able to knock off the unit in 2 days. It'll just give you a little bit of extra time to finish your assignment for finance, plus also potentially get caught up on anything that you've missed so far handing in. So this first lesson, we're going to go over a preview of exponent rules, the exponent laws, and be able to simplify using the exponent laws. And a lot of this first lesson is going to be a lot of 2-mark questions. You're going to have to, 1 mark is using your calculator, and 1 mark is being able to simplify using the laws that I give you today. So the first thing we are going to start with, what is a power? So let's say we have something that looks like this. 2 to the exponent 4. The first thing we're going to do with this actually is, how do you enter this into your calculator? So you are looking for, so I'm just going to using your calculator. You're looking for one of 2 buttons. You're looking for either a button that looks like this, x to the y, or y to the x, or, depending on your calculator, a button that looks like this. So you define that, and how you enter this in your calculator is, you're going to type in 2, and then one of those buttons. So one of those 3 buttons you got to find on your calculator. And then, so 2, one of those, 4, and you should get 16. Now, if any of you are having any problems and you don't get that or you can't find that button, you're going to have to ask me a question today at some point to make sure you know how to use your calculator, because that's a large portion of your test and being able to use exponents. So again, if you can't figure this out, where your button is, you're going to have to maybe send me a picture of your calculator, like take a screenshot of your calculator and email it to me, send it to me in Asia, or go into the Teams help and do the same thing so I can kind of help you with your calculator to figure this out. But again, make sure you get 2 to the exponent 4 equals 16. So now that we have kind of figured out, or hopefully we figured out how to enter this, we're going to go over some things. So this 2, that is considered the base. It's a base of 2. This 4 is the exponent. This whole thing So this whole thing, 2 to the exponent 4, is actually called a power of 2. And when it's written like this, that is exponential form. A base and then a superscript, meaning up top, written smaller, is an exponent. That's exponential form. Now, how does your calculator know that 2 to the 4 is 16? Like, what does 2 to the power of 4, 2 to the exponent of 4, what does that actually mean? Like, what are you doing? What you're doing is, just like how 2 squared or anything squared is something times itself, when it's written as an exponent, that means 2 times itself 4 times, or 4 2's. So this is the expanded form, and this is really what your calculator is doing. So 2 to the 4 equals 2 times 2 times 2 times 2. And if you were to enter that into your calculator, you should get 16. We are not going to do too much with expanded form other than just a couple of quick examples. We are going to focus on exponential form. You need to make sure that you know how to work with exponential form. Don't just rely on expanded form. So if you can't figure it out on your calculator, don't just be like, okay, well, I'm not going to tell Sulio, and I'm just going to, if I got like 2 to the 7, I'm just going to write in my calculator 2 times 2 times 2 7 times. It's not going to work for what we need it to work for. So make sure, again, you know how to use your calculator. And aside from going over what expanded form is, we're not going to do too much with it. So our first example, we are going to write each in expanded form and then evaluate. And again, this is just basically the only thing we're going to do with expanded form, just a little warm up here. 6 cubed really is 6 times 6 times 6, which if you enter that in your calculator, 216. 3 times 2, 3 squared, which is 3 times 3, then times, and then 2 cubed, which would be 2 times 2 times 2. If you enter that in your calculator, you should get 72. And then 6 squared is 6 times 6 plus 3 squared, 3 times 3. You can enter that in your calculator, 45. Again, very quick, kind of just warm up questions. The next thing, exponents only affect the numbers it touches. And this goes back to when I was helping you all with your calculators, back when we were face to face, why I was always encouraging you to enter brackets around things. And that has to do with different calculators and how they function. So on some of your calculators, if you were to enter it like A, you would get -9. Now, if that's you, that's fine. And if you're thinking, well, I thought anything squared is always positive. You are correct. However, realistically, really what that means, that exponent is only touching the 3 or only applied to the 3 and not the negative out front. So really what this is -1 times, and then 3 squared is 3 times 3, which is -9. Or, another way to look at this, that squared only applies to the 3, not the negative out front. So you have that negative, and then the base is 3 squared, which is negative, and then 3 squared is 9. Whereas, so there is a difference here. B is written differently than A. How is it different? The negative is inside of the brackets, meaning the base is -3. Here, the base is 3. Here, the base is -3. Those brackets are telling you to treat the negative with the 3. So really what this is really -3 times -3, right? The base and then times itself, which this is +9. And as a general rule of thumb, I have always told you that if you are using negative numbers, it's a good idea to enter them in brackets, and this is why. Then C, this is again just kind of a warm-up, don't worry about it. The 2, the squared, it's not applied to the x, so we have x. That 2 only goes, that squared only goes to the base of 2. That negative does not touch or is not applied to the squared, just like for b, how it was. And then 2 times 2, which would be x minus 4. But the key here really to these examples is you just understanding why you have to enter, or why I've been telling you when we were face to face, when you're dealing with integers and negatives in particular, to always put brackets around them when you're using exponents. And it's a good rule of thumb just to do it anyway whenever you're doing operations with negative integers. So that brings us to the lion's share of today's lesson, or this first lesson. Normally I would tell you in class, you got to have these rules memorized. Obviously, since your test is open book, you don't have to have them memorized since you can refer to it, but you want to make sure that you have a good knowledge of these exponent rules. So there are 5 we're going to do, 3 on this slide, 2 on the next one. Make sure you have a good knowledge base of doing these. And like with most math topics, practice makes perfect, so you're going to have to practice these. So our first one, the product rule. To multiply powers with the same base, keep the same base and add the exponents. So like I said, most of these questions are going to be 2 or 3 marks depending on the number of steps. 1 mark is you straight up entering them into your calculator. So for any question that we do, you could just enter into your calculator. If you do that though, you are only going to get 1 out of 2 or 1 out of 3. So right off the bat, you're setting yourself up to get 50% or less. So there's always going to be a mark for using your calculator, great, and another mark or 2 marks, depending on the number of steps, for actually doing these laws, these rules. So make sure you always do these rules first, use your calculator last. So the key here, the same base. So you can only use these rules if the base is the same. And if you've forgotten what the base is, refer back to our first opening slide with, what a power is. So we're going to do a couple of quick fire examples here. One with letters, one with numbers. So let's say we have a cubed times a to the 4. And we want to know what that equals. So we know we're going to use the product rule because we're multiplying and there's a multiply sign. The next thing you're going to check for is the base the same. And the base is this number, or in this case, letter. A and A, perfect. We can do this law. If it was A and B or A and any other letter, you can't do these. So what does it tell us to do? It says keep the same base, in this case, A, and add the exponents. What is 3 plus 4? 7. Done. Let's do it with some numbers. Let's say we have 2 squared times 2 to the 7. Is the base the same? Okay, so base and base is 2. Perfect. We know we can use this. We're multiplying. What does it tell us to do? Keep the same base. So write one of them, which is 2, and add the exponents. What is 2 plus 7? 9. Now I'm just going to do the examples with the laws. If this was a test question, it would say simplify using the exponent rules and evaluate, which would mean what we just did, we simplified with the exponent rules, that's worth a mark, and then typing 2 to the power of 9 in your calculator, that would be another mark. At this point, though, I'm going to assume everyone knows how to use their calculator. If not, you're asking me after the lesson. The next rule is the quotient rule. Quotient is just a fancy math word for divide. So to divide powers, again with the same base, keep the same base, and subtract the exponents. A couple of quick fire examples here. A to the exponent 8 divided by a to the exponent 5. First thing you're going to check for, is the base the same? It is. They're both a. So if it was a and b, or a and any other letter or number, can't do it. Can't simplify anyway. What does it tell us to do? Keep the same base, so a, and subtract. What's 8 minus 5? 3. Done. Let's put some numbers in. Let's say we have 3 to the 7. And instead of me writing divide, the other way you can express division as a fraction. So that's 3 to the 7 divided by 3 to the 5. Are they the same base? Yes, they're both 3. What does our rule say? Keep the same base, which is 3, and subtract the exponents. What's 7 minus 5? 2. And again, this would be a 2-mark question on a test. 1 mark for doing that, 1 mark for giving me the final answer, which would be 9 in this case. Our third exponent rule, power of a power. To simplify a power of a power, keep the base the same and multiply. Now, we probably don't know what a power to a power looks like, so let's see. So we have 1 power, a squared, and now we're going to raise it to another. So let's say 9. So a power to a power looks like this. It has 2 exponents side by side, or 1 exponent raised to another exponent. What does this tell you? Keep the base the same, so a, and multiply. 2 times 9, 18. Done. Let's try it with some numbers. So we have a power, and we raise it to another exponent or power. So we have back-to-back exponents. What does it tell us to do? Keep the base the same, 2, multiply the exponent, 6 times 2 is 12. That would be 1 mark. Another mark would be you entering 2 to the exponent 12 in your calculator and writing down the final answer. So there are our first 3 exponent rules. We're going to do the last 2. This second last one, so this fourth one, really easy. The 0 exponent rule. Anything to the power of 0 is always 1. That's an easy one to remember. So a to the power of 0, what does it tell you it is? 1. What about, I don't know, write a bunch of zeros here. What is that to the power of 0? 1. You don't believe me? Enter in your calculator. Try. What about, I don't know, this? All of that to the power of 0. What's that? Looks pretty intimidating, looks pretty crazy. Still just 1. Anything to the power of 0 is 1. Don't forget, anything to the power of 0 is 1. No matter how complicated it looks, anything to the power of 0 is 1. Now the last one. The last one's the trickiest one. Negative exponents. To deal with negative exponents, you simply flip, which just means invert, the base and make the exponent positive. So we're going to do a few different things here. So let's say we have this. We'll start with letters. A over b to the negative 2. We know we're going to use the exponent rule for negatives because my exponent is negative 2. What does this tell me to do? It says to flip the base. If I was to flip the base, my base is a over b. If I was to flip that, that becomes b over a. Then what does it tell me to do? It says make the exponent positive. So negative 2 is going to turn into positive 2. And then from there, that 2 goes to everything inside the brackets. So it would be b squared over a squared. Let's try it with some numbers. So let's say we have 1/3 to the negative 3. What are we supposed to do? We have a negative exponent. It says to flip it. That would be 3 over 1. Make your exponent positive. So become positive 3. And then that goes to everything inside the brackets. So 3 cubed over 1 cubed, which would end up being 27 over 1, which is just 27. Let's try another one. What if I had a to the negative 4? So we know we're going to use the negative exponent rule. And it says flip. But versus the first two that I did, it doesn't look like there's anything to flip. That doesn't mean it's impossible. It just, you kind of have to realize that, remember, any whole number, or anything that's not written as a fraction, really is written over 1. We don't write everything as over a 1 because it's redundant and it looks confusing, but again, anything that's a whole number is always over 1. Now there's actually something to flip. So this actually equals 1 over a. Make the exponent positive, which is 4, which this would be then 1 to the 4 over a to the 4, and 1 to the power of anything is 1 over a to the 4. Let's try it with a number. 2 to the negative 10. Again, doesn't look like there's anything to flip, but you have to remember, any whole number really is over 1. So if I flip that, 1/2, make my exponent positive 10, 1 to the power of 10 over 2 to the power of 10. 1 to the power of anything is 1 over 2 to the 10. So that's a tricky one. Maybe go back, listen to this again, recopy down, make sure you have your head wrapped around this. Thing we are going to do for this first part of our lesson, or part 1 of the lessons today, we're just going to do a bunch of examples using the laws we just saw. And again, these are going to be worth 2 marks, always on a test. 2 or more marks, depending on how many steps there are. So simplify and then evaluate. So this is the product law, and you know that because you're multiplying. What do you do when you multiply? You add the exponents. So 2 plus 3 is 5. That's 1 mark. The next mark, enter that in your calculator. You should get 7,776. The next one, quotient law. How do you know it's quotient law? You're dividing. When you divide, you do what to the exponent? Subtract. 5 minus 2 is 3, and then 7 to the 3, 343. The next one, power law. Exponent to another exponent. So for a power law, 3, you multiply. 4 times 3 is 12. And then 3 to the power of 12, I believe, 531,441. So far, hopefully not too bad. Now we have a fraction. Same thing, it's power law, because you have back-to-back exponents. So exponent to another exponent. 1/2. And you do what to the exponents again? You multiply. 3 times 2 is 6. So that's 1 to the 6 over 2 to the 6, which equals 1 over. And you just enter that in your calculator. 1 to the power of 6 is 1, or just remember 1 to the power of anything is 1. And 2 to the power of 6, enter that in your calculator, you should get 64. So 1 over 64. Next one. Now where you have some letters, same thing though. Now if you don't, bracket beside bracket means multiply. Remember, product law, add the exponents. X to the power of 11. And you can't get an answer, that's as far as you can go. F, a negative exponent. This is the last law we did. You have to flip it. It doesn't look like there's anything to flip here, so you have to remember it's really 3 over 1. Flip that. 1 over 3, make the exponent positive. 1 to the power of 4 is 1. 3 to the power of 4 is 81. So 1 over 81. This next one, those exponents only go to the letters, not the numbers. So all you do here is just multiply the coefficients. 3 times 4 is 12. And then you have like base and like base. So that's x. And since you're multiplying, you add the exponents. 3 plus 2 is 5. And that's as far as you can go. Last but not least, the easiest one, 27 to the power of 0, 1. Anything to the power of 0 is 1. That's it for your first lesson here on exponentials, exponent laws. Now you're going to do some questions in your workbook that I've referenced on D2L, and then come back and do part 2 of this lesson after you've done your workbook questions.